Alright, this video is your unit overview for Unit 4, Systems of Equations and Inequalities. So in this unit, students solve systems of linear equations exactly and approximately, for example with graphs, focusing on pairs of linear equations with two variables. Students determine the number of solutions a system of linear equations has, if any, and students solve systems of linear inequalities by graphing. Okay, so here are a few sample tasks that you will need to be able to complete in order to be proficient on this unit. So example 1 says, at what point does the graph x minus 2y equals negative 2 and the graph x plus 2y equals 6 intersect each other? So the solution to the system of these two equations is the point of intersection. So it's basically asking us to solve it by graphing. So here we need to write each equation in slope-intercept form. So first we have x minus 2y equals negative 2. So in order to write this in slope-intercept form, we're going to move the x using inverse operations. And we get negative 2y equals negative 1x minus 2. And then we're going to divide everything by negative 2 in order to isolate the variable. And we get y equals, a negative divided by a negative is positive 1/2 x plus 1. So in this equation, our slope is 1/2. So we're going to go up 1, forward 2, and our y-intercept is 0, 1. So these are the two things that we need in order to graph this equation. But before I graph it, I'm just going to go ahead and write this second equation in slope-intercept form. So I'm going to subtract x from both sides, and I get 2y equals negative 1x plus 6. Divide everything by 2. Y equals negative 1/2 x plus 3. So in this one, our slope is negative 1/2. So we're going to go up 1, back 2, and our y-intercept, is 0, 3. Okay, so let's go ahead and graph the first equation. So our y-intercept is 0, 1. This is our y-axis, this is our x-axis. And then our slope from the y-intercept is up 1 over 2, plot a point, up 1 over 2, plot a point. And now you need to use a straight edge. I'm going to use this Lego piece that I have here and connect the dots all the way across. Make sure you use a straight edge because you need these to be as accurate as possible. Alright, so our next y-intercept is 0, 3. And the slope is up 1, back 2, up 1, back 2. Again, I will use that straight edge. Whoops, sorry. And connect these dots. Okay, and you can see here is the point of intersection. And it intersects at 2, 2. Okay, so here we have some key ideas. Solving systems by graphing. The solution to the system. Is the point of intersection. Okay, slope-intercept form. And just slope. Okay, so we'll continue to just list our key ideas as we get through here so you know what it is you're going to be doing this unit. Next, it says to solve the system algebraically. There are two methods in solving systems algebraically, and the first one we're going to use is combination and elimination. So let's go ahead and write solving systems algebraically. And the first method is combination / elimination. Okay, so here we need to create opposites. That way when you combine the two systems, one of the variables will be eliminated, hence the name combination elimination. So here we have a positive 5. The opposite of positive 5 is negative 5. Here we have a negative 1. We can change that to a negative 5 by multiplying the entire equation by 5. And you end up with 20x minus 5y equals 40. So now I'm going to take that top equation and stack it underneath. And you can see that we now have opposites. Okay, so I'm going to identify my opposites by putting a little cloud around them. The reason we want opposites is then what we do is we combine the two equations and we get 21x, these equals 0, therefore it's eliminated, equals 63. Divide by 21 and x equals 3. Now remember, the solution to the system is the point of intersection, so we're looking for a coordinate here, so we are not done. We're going to take this x and plug it into either of the original equations, and in this case I'm going to choose the top one, okay, and solve for the other variable. So I end up with 3 plus 5y equals 23. Subtract 3 from both sides, because now we're just isolating the y. And y equals 4. And you have to write your solution as an ordered pair. So the solution for this one is 3, 4. Make sure that you put your x value first. So we can add here substitution, which is actually the next method of solving systems algebraically. Alright, so let's look at this next task here. It says, Jared has volunteered 50 hours and plans to volunteer 3 hours in each coming week. Clementine is a new volunteer who plans to volunteer 5 hours each week. Write and solve a system, that means two linear equations, to find out how long it will be before they have volunteered the same number of hours. Okay, so for Jared, he started with 50 hours, and then he's adding 3 per week. Okay, so 3w, and that'll equal h, his total hours. The question here was, how long will it take before they have volunteered the same number of hours? So I'm making h be the total number of hours. Now Clementine is starting with 0 hours, but he's also adding 5 per week to make his total hours. Now here we're going to use substitution because you'll notice that each of these are solved for a variable already. So in this one we have h equals 5w, and it can be written like this, h equals 5w, or you can just realize that you're going to take this 5w and substitute it into the other equation for h. So here we'll get 50 plus 3w equals 5w, and now we'll just solve for w. So I'm going to move this 3w to the other side using inverse operations, and I get 50 equals 2w, divide by 2, and we get 25 equals w. So here we've answered the question. It will take 25 weeks for them to have volunteered the same number of hours. Now, we could find out how many hours that is. Here we're done, but just to show you that you can then go back and take what you found for W and you can plug it in to one of the equations. Let's do this one, the other one, and find out the number of hours. So here we have 5 times 25 equals h, which is 125. So here In 25 weeks, they will both have volunteered for 25 hours. So you'll notice we have some skills on writing equations given real life situations. And the method we used to solve was the substitution, which we already wrote. You also have to be able to solve systems of inequalities. And the way that you solve systems of inequalities is by graphing. So let's go ahead and write solving systems of inequalities. Now you have to graph them. And you have to determine if you're going to have a solid or dashed line, and if you're going to shade up or down. Okay, so let's go ahead and write each of these inequalities in slope-intercept form. So I'm going to subtract 2x from both sides. And I have negative 3y is greater than negative 2x plus 6. Divide both sides by negative 3. Now remember with inequalities, and kids tend to forget this a lot, is that when you divide by a negative, you have to flip the symbol. Here our slope is 2/3, so we're going to go up 2, forward 3. Our y-intercept is 0, negative 2. Since there's not an equal to symbol here, we're going to have a dashed line. And since y is less than, we're going to shade down. Now for this one, before we graph it, we might as well go ahead and write this one in slope-intercept form. So we're going to add 4x to both sides. And we get 2y is greater than or equal to 4x plus 8. Divide everything by 2. Y is greater than or equal to 2x plus 4. Our slope here, written as a fraction for rise over run, is 2/1. So we're going to go up 2, forward 1. And our y-intercept is 0, 4. This one has an equal to, so it's going to be a solid line, and we're going to shade up because its y is greater than. Now you want to make sure and graph your whole equation, including the shading, before doing the second one. So we're going to do our y-intercept at 0, -2, and then we're going to go up 2/3, up 2/3. Again, grabbing my straight edge, I'm going to make a dashed line all the way across my coordinate plane. And I'm going to grab a pencil and shade down, all the way down below this line, and make sure you fill your whole coordinate plane with the shading. So my next y-intercept is 0, 4, 1, 2, 3, 4, plot my point, and then I'm going to go up 2, forward 1, up 2, forward 1. Once I have 3 dots, I can grab my straight edge. This is going to be a solid line. And then this one, it says shade up. So you're going to start shading down across this whole line up. So above the line is here. And then you'll see where the two shades intersect, and you're going to make that piece darker. So the solution to the system of inequalities is this shaded region. All right?